Hello, one. So we have a number 23 now. So this was the next question. So triangle ABC has three sides are given, and then bisector of B and the altitude to side AB intersect at a point P. What is BP? So let's draw the diagram. Okay, so let's say this is my A, B, and C. So it is given AB is 80, and BC is like 45 and 75. And the bisector of B, which should be something like this, then altitude to the side AB. So let's say this is the altitude. Okay, so then there's an intersection, which is P right here. Now we want this guy. Okay, so like this kind of reminding me of one of the recent stuff actually did on, I guess, did some pros. So the angle bisector length formula. So you can try kind of finding the BP if you know this segment, and this segment, as well as this segment. So you can use the Theorem for sure. That was also another video I actually did a few weeks ago, or maybe 2 weeks ago, or whatever. But let's try to see what we can do with this first. So since the numbers are kind of quite big, maybe I don't want to deal with those numbers. Maybe I will just work with the smaller scale, and then I'll just kind of double that, multiply by whatever I need to. So like what I'm saying is, let's actually try differently, because sometimes it's actually better than actually working with the given numbers, because you don't need to do a lot of computations. Anyway, so when you look at these numbers like 80, 75, and 45, they're all divided by 5. So if you divide by 5, so you got 16 and 15 and 9. So I can just take those numbers like 9 and 15, and then this is 16. And I can easily find this height because that's kind of what I need as well, since I'm going to need to get this segment. So I'll just use the maybe Heron's formula. So with this one, so the 15, 24, when you add those, so let's say S is like 15 plus 9 plus 16 over 2, which looks like 20, right? So the area has to be 20 times 20 minus 9 is 11, 20 minus 15 is 5, 20 minus 16 is 4, and we take the square root of this. And we need to the 5 and 20, that's 100. So that's 400. So 400 will go as 20. And then root 11 will be stay inside. Okay, this is the area. And I can take the height times base over 2 to get the number. So 20 root 11 is going to be height times 16 over 2. So that's going to give us 8 times this, divide by maybe 8. So the h will be like divide by 4. So you'll get 5 root 11 over 2. Okay, so that is something. So now we can just find this leg, because we know the height right here, so we can use the Pythagorean. I'm gonna call, let's say this was B, right? So I'm gonna call this is T. So the BT squared is equal to 81 minus the square of this one. So you got 25 times 11 over 4, and that's just Pythag. And then that will give us like 4 times this will be like 324 minus, like if you have 425s, that's 100, but that's one lesser than 1225, so that should be like 275. And then that's 25 plus 24, which is 49 over 4. So that means BT will be just 7 over 2. So we got this one as 7 over 2. Since we have the angle bisector right here as BP, so we can use angle bisector theorem, so which is something we always use. So 7/2 divided by 9 is 7 over 18, which means the ratio of this to this is also 7 over 18. So if I call this is like 7, like K, this is going to be 18K, right? So then this guy, TP, has to be 7/25 of the entire TC, since we know the height was this 5 root 11 over 2. So I can just cancel this. So you will get 7 root 11 over 10. And then similarly, so the PC should be like 18 out of 25th of that height, so which is 5 root 11 over 2 again. So you will cancel these ones, and then you cancel those. I'm probably going to cancel it to make less numbers. So 9 root 11 over 5. Okay, so now we can use the angle bisector length formula. So I'm going to say this is our x. So the x squared is equal to product of this leg times this leg minus this times this. Again, if you don't know about the angle bisector length formula, I'm going to include that proof in the description. You can take a look at that one, so because it's useful. Or you can just use this theorem, so which is going to be also fine. And like what we have now, 7/2 times 9 minus the 7 root 11 over 10 times 9 root 11 over 5. Okay, let's simplify this one. So you got 63 over 2. And minus, we can just say there's no really cancellation, but 63 is there again, which is good, times 11 over 50. And then, we can take the 63 over like 2. Maybe I can pull the 63 as a factor. So if I do that, so you get 1/2 minus 11 out of 50. And, this is, I can multiply by 25. So 25 minus 11 will be 14 over 50. And that will be 7 and 25, which is good. So this has 7 already, and then 9. So if I take the square root of both sides, so then the x should be, the 9 will be 3, and then 7 will be, 7 squared will be 7, and then 25 will be 5. So let me double check. So again, the 9 times 7 times 7, so 9 will be 3 when you take the square root. So 21 over 5. So like we got x as 21 over 5, but this is the triangle I actually scaled down, right? So this was actually these numbers. So when I did divide by 5, so I actually divide everything by 5. So the x is like 21 over 5. If I multiply by 5, so you end up getting this guy to be 21, which is choice C. So I hope that's clear. So I'll see you in the next videos.